Hi there. In this video, we are going to discuss about the Maclaurin series. So far as in a previous video, we have discussed about the Taylor series expansion. We have seen in the first lecture that is the Taylor series theorem and example based on the different forms of Taylor series. That was already we have discussed. There are lots of questions arises that how we can represent the functions f of x plus pi by 4 or sine of x plus pi by 4 can be represented, and based on that you can represent the graph. So here this is the first example. Sine of pi by 4 plus x, that is 1 divided by under root 2 plus x into 1 divided by under root 2 plus x square divided by 2 factorial into minus 1 divided by 2 under root 2 plus and so on. And this is the expression in power of x. And suppose you want to estimate the graph, and that you can. So graph will be like that. Today we are going to discuss about the Maclaurin series. So first question arises how we can get the Maclaurin series. But already we have discussed that if the Taylor series expansion about a is equal 0, then it is going to be the Maclaurin series. So just put here a is equal 0 and the form will be here f of x is equal f of 0 plus x divided by 1 factorial f dash at 0 plus and so on. This is the Maclaurin series representation, and we will keep in mind. So what are the use of this Maclaurin series? Suppose you have given that any function, and that function can be represented in power of x, and that is, and based on that we can estimate the graph. So here also you can estimate the approximate value. Now we are going to discuss about the example based on the Maclaurin series. So first question is obtain Maclaurin series of the function f of x is equal sin x. So already you are familiar with the graph of the sin x, but question arises that how we can estimate based on the Maclaurin series, and that is we are going to learn here. So yeah, so let's have a solution. So this is our Maclaurin series expansion. So for that what we are going to consider based on f of x is equal sin x. So based on that we have to determine f of 0, f dash at 0, f double dash at 0 plus and so on. So here first f of x is there, that is sin x. So at 0 f of 0, that is sin 0, that is going to be 0. First derivative of the function, that is derivative of sin, that is the cos x, so that is we have. So first derivative at 0 cos 0, that is 1. Second derivative, that is the minus sin x, and second derivative at 0, that is 0. Third derivative, that is a minus cos x, and at 0 that is going to be minus 1 and so on. Now we substitute all these value in the given form, and that is our Maclaurin series. And if we substitute all these value, then the sin x is going to be x divided by 1 factorial plus x square divided by 2 factorial into 0 plus x raised to cube divided by 3 factorial into minus 1 plus and so on. But when we simplify this term and we get the here expansion of the sin x, that is sin x is equal x divided by 1 factorial minus x cube divided by 3 factorial plus x raised to 5 divided by 5 factorial minus x raised to 7 divided by 7 factorial and so on. Now our question arises how we can estimate the function graphical representation, that is we are going to see here. So here suppose you have first degree, so I will denote here f of x is equal x, so that polynomial can be written as p1. If I say polynomial of degree 2, so that will be the x square. P3, then it will be the polynomial of 3. P5, polynomial of degree 5. So based on that I have here just represented. So here you can see that y p1x is equal x. That line you can see from the first figure. If I assume P3, that means polynomial of the degree 3, so I have to consider first two terms, x divided by 1 factorial minus x cube divided by 3 factorial, and if we represent that, so our graph becomes second one. But if we add third terms, first, second and third, so we get the P5, that is fifth degree of the polynomial, so that form will be here, that you can see. And if I say P7, that means 7th degree polynomial, and that means I have to add the first 4 terms and we get this graph, and exactly it estimates the graph, that is sin x. So that means when we add the number of terms to the expression, and the resulting graph will be approximation whatever you want the graph, and that is the nice one. Similarly, there are some standard forms that you can represent in the Maclaurin series form. So here cos x is there, so 1 minus x square divided by 2 factorial plus x raised to 4 divided by 4 factorial plus and so on. So for that, what you have to do? Suppose you want to prove that cos x is equal 1 minus x square divided by 2 factorial plus x raised to 4 divided by 4 factorial plus and so on. So in that case, what you have to consider? So from this question, you can conclude that we want sin x in terms of x. That means we need to represent here Maclaurin series expansion of the function f of x is equal cos x. So here f of x is equal cos x is there. So our target is to what? To determine f of 0, f dash at 0, f double dash at 0 and so on. And we will put all these value in the Maclaurin series expansion, and after simplification you will get the cos x is equal 1 minus x square divided by 2 factorial plus x raised to 4 divided by 4 factorial plus and so on, and that you can. So I am not going to represent that thing. So here another function that is e raised to x exponential 1 plus x divided by 1 factorial plus x square divided by 2 factorial plus x raised to cube divided by 3 factorial plus and so on. And this is the exponential function, and clearly if we add the values of x, then the graph is going to be very large. So that means if we consider e raised to power 2, and that also you can estimate based on this expansion. That means what you have to consider, just put your x is equal to and e raised to 2, that will be 1 plus 2 plus 4 divided by 2 factorial plus 2 raised to cube divided by 3 factorial plus. If you estimate only first 4 terms, and in that case you will get the approximate answer. But if you add larger and larger terms, you will get the more approximation answer. That is the good concept of this expression, say Maclaurin series. And this is another function, that is e raised to minus x. That means what you need to represent from the above expression. If x is replaced by minus x, the resulting form will be e raised to minus x. Again you can derive. So f of x is equal to e raised to minus x. So again you have to use the Maclaurin series representation, and for that you have to determine f of 0, f dash at 0, f double dash at 0 and so on. And you can get this expression. And this is another. This is the cos hyperbolic x. But we know that cos hyperbolic x is what exactly? E raised to x plus e raised to minus x divided by 2. That means I have to add e raised to x plus e raised to minus x, and I have to consider average of these two functions, and the form will be 1 plus x square divided by 2 factorial plus x raised to 4 divided by 4 factorial plus and so on. That means what we have derived here, just expansion of the cos hyperbolic x. There is no need to consider only e raised to x and e raised to minus x. Without this also you can estimate. For that, what you have to consider? F of x is equal cos hyperbolic x. Derivative of the cos hyperbolic x, that is sin hyperbolic x. Again derivative of sin, that is the cos hyperbolic. So similarly you have to alternate, consider the derivative, and you have to determine the particular value of all the derivative at x is equal 0, and you have to use the Maclaurin series expansion. Also you can get the same answer. So what are the differences between the cos hyperbolic and the here cos x? So cos x, that is you can see first formula, all the terms are alternate, but here you can see all the terms are what? Exactly positive, because there is no negative terms will be there. And again derivative of the cos hyperbolic x is never be negative, and that is we know. From that, how there are lots of students question arises that, sir, how we can say the derivative is not negative? How we can say? So here cos hyperbolic x is there, already we have represented e raised to x plus e raised to minus x divided by 2. But if I apply d by dx of cos hyperbolic x, so d by dx of e raised to x plus e raised to minus x by 2. But if I apply the linearity property, so d by dx of exponential e raised to x plus d by dx of e raised to minus x, and we assume that divide by 2. So first e raised to x minus e raised to minus x divided by 2, and that is what exactly sin hyperbolic x. So in that case, there is no chance to have the negative representation of the derivative. That is also you can derive from this formula. And another, that is the sine hyperbolic x, already we have discussed, x plus x raised to cube divided by 3 factorial plus x raised to 5 divided by 5 factorial plus and so on. And again, also you can estimate tan x, x plus x cubed by 3 plus 2x raised to 5 divided by 15 plus and so on. So this is 1 divided by 1 plus x. Also you can derive this expression based on the Maclaurin series. But we will keep in mind, because this expression we will use later on. 1 minus x plus x square minus x cube plus and so on. But if I consider 1 divided by 1 minus x, that means what I am just going to consider from the above expression, x is replaced by minus x. The resulting form will be 1 minus n minus x, that is going to be plus. So 1 plus x plus minus x raised to power 2, that is x square, minus of x raised to power 3, that is plus x raised to cube plus and so on. And that is the nice expression. We will keep in mind these two expressions we will use later on. Another, this is the binomial expression, that is also you can derive based on the Maclaurin series. So just keep in mind, and this is called the binomial expansion. So now formation of the graphs using the Maclaurin series. So this is the sine function, already we discussed. This is the graph of the sine function. First y is equal x, then 2 terms, 3 terms, 4 terms, 5 terms, and based on that we can estimate the graph of the sine function. Similarly, this is a better model of the sine function, that you can understand why we are using sometimes the real life problems. So here y is equal x, that is already we have denoted as a bracket x, and that will be the line. Minus x cube divided by 3 factorial, our graph is going to be below side. Then if we add the 3 terms, so our graph is going to be like up to 3 terms, then and so on. So this is the better model of sin x, that also you can compare with this. So this is the graph of the cos x function. Also you can understand, first one 1, then minus x square divided by 2 factorial. If we adding successive terms, then we will get this graph. This is the exponential function, also you can estimate the graph. So first 1, then 1 plus x, then 1 plus x squared by 2 factorial. So the graph is look like the exponentially, but that means function is going to be very large when x is going to be very large. So 1 divided by 1 plus x, this is the expression is that. But we want here representation of the graph. So this is what exactly 1 divided by 1 plus x, that is you can see from the figure. Also you can see the graph of 1 divided by 1 minus x. So that is 1, then plus x square. So the graph is like that one. So this is the graph of the 1 divided by 1 minus x. This is the log of 1 plus x, x minus x squared by 2 plus x cubed by 3 plus and so on. Also you can derive this expression based on the Maclaurin series expansion. So this is the graph. Here you can see first x, then first 2 terms, then first 3 terms. So the graph is look like that. Now let us look at the example. This is a very most important question. Obtain Maclaurin series of the log 1 plus x to the base e and find the series of the log 1 plus x divided by 1 minus x to the base e, and hence find the estimate function log 11 divided by 9 to the base e. So first what we are going to consider Maclaurin series expansion. So for that we have to consider function f of x, that is log 1 plus x. So this is the f of x is equal log 1 plus x. So at 0 we get the answer 0. First derivative, that is 1 divided by 1 plus x, at 0 we get 1. Second derivative at 0 minus 1. Third derivative that 0, that is 2 and so on. But after substituting all these successive differentiation at 0, we get this representation, and finally we get log 1 plus x to the base is equal x minus x squared divided by 2 plus x raised to cube divided by 3 plus and so on. And if we replace x by minus x, so what we get log 1 minus x to the base e minus x minus x squared divided by 2, that will be the minus x squared by 2. That means all the terms will be negative. and ultimately our target what was log 1 plus x divided by 1 minus x basic, that is we want to represent in the Maclaurin series form. That means we can here write log a divided by b is equal log a minus log b. So here log 1 plus x minus log 1 minus x, already we have derived the first and second expression and we put by 1 minus x is equal to x plus 2x cube divided by 3 plus and so on. And that is what exactly required Maclaurin series. But our question says that we want to estimate this function at particular point. So in that case we have to consider here x is equal 1 divided by 10, so that log 1 plus 1 divided by 10 divided by 1 minus 1 divided by 10, that is going to be log e 11 by 9. And again, just if we put x is equal 1 divided by 10 in the above expression, we get, based on the calculator, we get 0.2006, and that is we want. That means suppose you have given that any function that we are not able to consider direct answer. So in such cases, based on the Maclaurin series, you can estimate the function at particular point. So in this lecture, we have discussed about the Maclaurin series expansion, how the function can be represented as a graphical, how the function can estimate at particular value, and that thing we have seen in this video. In the next video, we will discuss about the Maclaurin series, but we will consider the differentiation and integration concept, and based on that also you can estimate the function. Thank you for watching.